Okay, so a similar concept for part B, dp dx evaluated at x equals 3. If you remember way back, this means the same thing as p of 3. So I need to find p of x, which I believe is given to me up here. Yeah, it's f of x times g of x. I need the derivative. So that's the first times the derivative of the second plus the second times the derivative of the first. So I have this memorized by now, but it really is not a big deal if you just have it on your note card and you always just look at your note card. But I know that this is multiplication, so I need the product rule, which I've memorized and I just wrote here. Now I'm supposed to plug in 3, so p prime of 3, f of 3 times g prime of 3 plus g of 3 times f prime of 3. So all those values are given to me up here. So I need f of 3 and g prime of 3. F of 3 is 7. G prime of 3 is 3/2. And then I need to add to it g of 3 plus times f prime of 3. G of 3 is -2. F prime of 3 is -1. Okay, so simplifying, 7 times 3/2 is 21/2. And then -2 times -1 is just going to be +2. 21 divided by 2 is 10.5, so I think this is 12.5. Okay, so we've learned the product rule and we've learned the quotient rule. Now we're going to use the quotient rule on this new thing called average cost. So average cost is the average cost to produce a single item. So for instance, let's say it costs you $300 to make 1,000 cookies. So 300 divided by 1,000 tells you the average cost for each cookie. So it looks like average cost is C of x divided by x. If you remember, C of x is the cost to produce x items. So that would make sense, right? The cost to produce x items divided by the number of items gives you the average cost per item. So let's put this to work. A company estimates that the cost in dollars of producing x units can be modeled by this function. Find the production level that minimizes the average cost. Okay, so writing this out, the objective is to minimize average cost. Okay, so I will find average cost. I do that by taking my cost function, which was given to me, and then dividing it by x. So at this point, there's a lot of different ways to do this problem. I'm just going to use one way because it uses the quotient rule, which we just learned. So if I want to minimize the average cost, that means I need to take the derivative and set it equal to 0 so that I find the critical points. So if I'm going to take the derivative, though, this is almost certainly a quotient rule problem. So I have the quotient rule memorized. If you don't, it would be totally okay to just have it on a note card. I really think you should have it on a note card and look at it that way. But I remember it because I've done it a million times, and it's the bottom times the derivative of the top, and I'm just going to do this symbolically for the moment, and just like put a prime at the end, minus the top times the derivative of the bottom. And actually that's easy. The derivative of x is just 1, so I don't even need to worry about that. And then all over the bottom squared. Okay, now let's see. I need to take a derivative here. So I've got x times And then the derivative of 0.001x cubed is just going to be 0.003x squared minus 5, and then minus 0.001x cubed plus 5x minus 250 all over x squared. Okay, so this is my derivative. Oh, and I forgot to put a prime here. This is my derivative. So I'd set this equal to figure out what the critical points are. So critical points are where the derivative is equal to 0 or where the derivative is undefined. And I have one place where the derivative is undefined. That's x equals 0. The only trouble, though, is x equals 0 would be 0 units, like the company produced 0 units. So I'm pretty confident that is not that's not a good thing. Like they have to make at least 1 unit in order to make any money. They just have to make a unit. So I'm going to ignore that solution and just solve to see what the critical points are by setting it equal to 0. And the first thing I could do is multiply both sides by x squared, and then x squared goes away. So this is now just a game of trying to solve the top. So I have x times 0.003x squared minus 5 oh, I don't have room for that. Okay, so, and actually let's multiply the top out. So the top would be 0.003x cubed minus 5x minus 0.001x cubed plus 5x minus 250, and it should equal 0. I didn't come up with this problem, but I'm glad that whoever did do it, because this cancels, which is really nice. And then 0.003x cubed minus 0.001x cubed, that's actually pretty easy. That's just going to be 0.02x cubed. So those, I got rid of those. Minus 250 equals 0. And I could add 250 to the other side. 0.02x cubed equals 250. Dividing by 0.002, x cubed equals 250 divided by 0.002, which I'm going to have to use a calculator for that. Okay, 250 divided by 0.002, it's going to be something huge, 125,000. So x cubed equals 125,000. Cube rooted, if I do that to both sides, the cube root of 125,000 is probably like 50,000. Let's see. Oh, I'm not even sure this calculator does that. Yeah, I don't think this calculator does. I'm pretty sure that's 50,000. I can check my work by multiplying 50,000 by itself 3 times. So see how that works. Oh, no, that was not right. Maybe it's 5,000. Also not that. Okay, I am going to use the internet. Let's see. Cube root. Sorry, I've only got a really crappy calculator. Okay, Google says the cube is 50. Dang, man, I was really close, but wrong every time. Okay, it is 50. So x equals 50. So let's make sure this makes sense. A company estimates that the cost in dollars of producing X units can be modeled by C of X equals blah, blah, blah. Find the production level that minimizes the average cost. So this would be 50. This would say that I should produce 50 items. And that makes sense. So I think we'll keep that. Okay, if there are any questions, ask them on the discussion board.